Okay, we're recording. Okay, so 5.2.3. And by the way, the test got moved. It's not next week. So it got moved. Okay. Yeah, good news, right? So the test dates have been kind of all shifted as a result. So it's not until Monday, January 29th. So we have 3 meetings next week, so we're back to a 5-day week, right? So I don't know what we're covering next Monday. I'm actually going to deal with the Algebra 2 teachers later this afternoon, but we'll probably do another lesson, probably graphs. Well, we're doing graphs today, but we're going to talk more about graphs and logs on Monday. Probably Wednesday, we wrap things up, and then we'll have a full review day on Thursday. Maybe I might even do 2 review days. If you're curious if I'll be available for a Zoom session the night before the test, just to let you know, January 28th is the NFC Championship game. If the Niners win on Saturday, they're going to be playing that game on Sunday, which will be at 3:30 and probably finish till 7. Probably not going to be available. Just saying. If Niners lose, maybe I'll be available. We'll see. I don't know. But I'll make sure I'm available next week like crazy, right? And of course, we have office hours on the 29th, right? Office hours actually before C period, so I'll be available to help you guys there. But the night before, probably not. Just saying. Okay. And I'm either gonna be really happy or really sad. So we'll see. Like last year, I was really sad because Jack was really happy last year, right? Right, Jack, when Philadelphia beat the Niners. Yeah. Okay. You're over football. And stop text. You just finish your text. Okay, got it. What's that?
He's watching hockey at this point.
Hockey now? Okay. Or are you a Philadelphia Sixers fan or?
No, he's only Philadelphia to my followers.
Only Philadelphia follows the Eagles. Got it. Okay. All right, I like this. Okay. Well, anyway, guys, let's get started. Sorry about that. I got us off track. Okay, so let's get started. So yeah, test is not next week, the week after. It's on 29th. Okay. So yeah, so let's talk about finding inverses, right? So just switching x and y, right? So if I want to find the inverse of 571 part A, switch x and y, right? We know this. So that's what I did first. Now remember, what is the meaning of a log? If you have log base b x equals y, it's the same exact thing as x equals b to the y power, right? So whatever was the input of the log now becomes the output of the exponential function, right? Is there inverses? Whatever was the output of the log is now the input of the exponential function. So now y is the exponent. Where y was on a side by itself, now y is not a side by itself. Where x is part of the log, now it's by itself. So that's what I have to do here. So if I want to get y by itself here, if I want to get y by itself, I would just say y equals 9 to the x power. And that's it. That's your inverse. That's the inverse of part A. What did I just do? I took this 9 here and raised it that power. And the y is now on its own. That's why we have logs. This helps us isolate exponents. So same thing here. We'll switch colors for a bit of contrast. Ooh, light blue is kind of nice color. So x equals 10 to the y power. So does that look pretty close to this, right? That looks pretty close, right? What's in b's position? What's in b's position? And y is y, right? So now I just got to write like this. So if I want to get this y by itself, and I don't want this y is an input, I want that to be an output, right? Now what's the base of this? 10. So 10 is going to be a base for log. So what do I write? Y equals log base 10x. Y equals log base 10x. We keep going. Let's go green here. Switch x and y. That's a 6, by the way. It kind of looks like a B. That's supposed to be a 6. Maybe give it a little more curved. Sorry about that. Let's make it a little more curved. Okie dokie. So the y plus 1 is the input. Now that becomes the output. So y plus 1 equals 6 to the x power. And guess what? Y will be 6 to the x, then minus 1. And lastly, 6 to the x minus 1.
No, because it was plus one over here that I had to move it over.
Okay. So switch x and y again. X equals 5 to the 2y power. So 2y now becomes the output and equals log base 5 of x. And guess what? Y will be all that divided by 2. Or you can say 1/2. And there we go. That's part D. That's fine too. The whole thing over 2. Not just x over 2, it's be the whole log over 2. Very, very important. Because then you're switching things up, which is not good. Yeah, so that's what we do, guys. Questions? No? All right. So let's do more practice of logs here. And without changing the expression in exponential forms, just kind of think about it. Oh, do you need me to? Nope, no worries, no worries. Here we go. Yeah, and so this extra packet I have is called the meaning of logarithms. I'm gonna give that to you guys after I finish these notes, because you guys really do need it. It's as I said, this is definitely a challenging unit. But we're gonna spend more time with this. And I'm glad we moved the test, to the following week. We're still gonna have another unit on logs, not the second unit, but the third unit, like sometime in March. Ooh, I gotta plug my laptop. Hold on. Sweet. Okay. All right, let's keep moving, guys. So next up, let's work these out. And what I'm going to do is set these equals. Remember, we said y equals log base bx is the same thing as saying x equals b to the y power, right? We said that, right? So what if I just put y here in each case? So what does this mean? Like, well, I'll start with part B. 81 equals 3 to the y power. So what does y have to be to make that work? What's y equal, guys? 3 to the y power gets me 81. It's 4. There you go. Yep. Even though I'm not following the instructions, I am changing it to exponential form. I think you guys still need to see that. You guys still need to see that. But sometimes you can get pretty quick with this. Like, maybe we don't need to do that for A.
So 7 to what power is 49? So that's 2. Part A is 2. Yeah.
And while I'm at it, maybe I could just erase this now and just say it's 4, right? For part B. Because once you get very good at this, you just move fast, right?
Like, yeah. 3 to the 4 is 81. You know, I'm going to get rid of
these y's here. I think we could do this without. Yeah, I know. I think I agree with the bold is saying without bold and italics, without changing expression to exponential form. So yeah, just think about it. Okay.
So 5 to what power equals 5 to the 7? What are they here, John? So 7. How about here? 10 to what power equals all this? We have here. All 2. Here, 3. 2 to what power equals all this? 2 to what? That's 3. Yes. Very good.
Outstanding. Outstanding work. Yes. Yes. They cancel out. You got it. Yes, that's the takeaway. Perfect. I love it. Yeah, when the base of the log equals the base of the exponential expression that is being logged, Hold on, let me just that. Perfect. Yes. When the base of the log,
So let's look at C again. What's the base of the log here? 5. The exponential expression, what's the base of that? 5 also. When those are the same, they undo each other. Well, what's the leftover answer? The exponent. They undo each other. Now, can I do that for A and B? Yeah.
I could have rewritten. A could have been rewritten like this. I could have said A. Log base 7 of 7 squared equals 2, right? Because isn't 7 squared 49? I could have done this also. Log base 3 of 3 to the 4 power equals 4. Because 3 to the 4 is 81. You totally could do that. Yep. So that's huge. Now, some students will do this. I'm not going to encourage this behavior because it's not good. Some students will do this. This will make your pre-calculus teachers cringe if you do that next year. It's not technically what's happening because you're not dividing. Now, when you have like 10x over 10, we do this, right? Why do we do that? Because that's division. Because 10 times x, opposite of division, multiplication division. That's okay, right? We could totally do that. Or when you have an equation, like if you have 10 plus x equals 5, you subtract 10 from both sides, right? And you do that. Yeah, totally fine, right? Not a problem. Can't quite do that, but they do undo each other, meaning they're opposite of each other, right? Exponential and logarithmic. So yeah, but that's good. I'm glad you guys see that. Perfect. Okay. This is the last bit of notes before I talk about meaning of the other worksheet, the meaning of logarithms, because we want to make sure we get some drill and kill here. We do have to talk about graphs of these. We're not going to create a poster. I'm just going to kind of do this with you guys. And let's choose a specific B value. I'm going to choose a value for you just to make life a little easier. Let's have B equal 2. So this becomes y equals log base 2 of x. Or x equals 2 to the y power. Does that make sense? X equals 2 to the y power? Yep. Okay. So let's make a table. So I got an equation. Let's make a table now. I'll do the table right below. Here's the problem.
Well, it's not really a problem. Y is input. As it should be. This came from a log, right? Remember, this is the inverse of y equals 2 to the x, right? Remember, this is the inverse. For y equals 2 to the x. Where x is everything for y opposite. Now it's the reverse.
So what I'm going to do is I'm going to plug in for y. Yeah, go ahead. No, because you go then you'd be graphing the exponential function, not the inverse.
Oh.
Right. So y is now my input, and that's easy. That's 1, 2, and 1/2. So now I'm going to do a graph. I'll do the graph right over here. 1, 2, 1, 2, 1, 2, 1, 2. So 1 comma 0, 2 comma 1, half comma negative 1. The graph is going to look like this. By the way, just we compare, y equals 2 to the x is going to look like this, right? Where the green is x equals 2 to the y. Those are inverses, right?
And y is x is right to the middle. Yes, but
Why on the B to why is
I chose that. That's my choice.
Yeah.
Let's focus.
If you put that on the class, you know.
No, I'll give you one. Yeah. I say for this activity, I'm choosing it.
So brief description of the graph. Well, you could probably just say the inverse of y equals 2 to the x. Right? Well, that's a little messy. The domain is going to be x is greater than 0 or 0 to infinity. The range is all real numbers, or will be that. And the equation of any asymptotes is x equals 0. And again, y equals x goes right to the middle of it. And remember, what you see here in green is the same as that. Those are the same thing.
Y is log base 2x, take 2 y. The same. It's just get it right like this. It's easy to fathom what you're doing. Like, oh yeah, 2 to the power. But remember, y is now the exponent, not x, right? It's reverse compared to what's in graph. Reverse, as should be. Remember. So that's how a log graph looks. Log graph is vertical, whereas this has a bit more horizontal, right? I mean, yes, it's vertical over here, but this has a horizontal asymptote, like it's really low and scoops up like this. This actually shoots down this way, right? It does that. So log curves look like this. We'll talk about the transformations of them on Monday.
I think that's a good opportunity to do that then. Questions? No? Okay, but at least I kind of felt like I've done a more proper introduction to log graphs. We didn't generate 4 points. 3 points is enough. 3 point, like let 0, 1, and -1 be the y coordinates, and that's good enough. You get the curvature there. Now, and again, I don't expect you guys to really fully grasp this just yet. We're going to talk more about next week. That's why we moved the test. Alex, good.
When you're doing,
Mhm.
when you try to graph it on your calculator, how would you do that?
Oh, good question. So you're gonna hit alpha window called blocks.
Or would you do log base?
Yeah, look, yep,
Okay.
Yep. Yep. X equals 0. Well, for the brown, it's y equals 0. For the brown. Alpha and then window. You just do log after you hit alpha in the window. Yeah, but when you have that up there. Like, just say whatever you can. Don't worry about it. I haven't inventoried homework yet. I'm gonna do it this weekend, so don't worry about it.
Yep. Okay. I gave you guys a new packet, and really quickly, for those who ask about the calculator. So if you want to graph in the TI-84 calculator, Desmos, you just have to click on the keyboard and pull up the functions because it's a little tricky. I don't know what the shortcut keyboard strokes are. I don't know that. I'm sure that there's a to look it up. I could probably figure it out, but kind of lazy right now. Let me clear the screen. Yeah, so if I were to do this in the calculator, go to y equals, hit alpha, then window, option 5, and you can do that. And there's a log graph. It's a little weird because it looks like it blends in with the y-axis. If you were to actually update the window, like, I don't know, go from like 0 to like 4, let's say, and make that a little more fine, like 0.5. You see it's pretty close to the y-axis. I mean, if I were to trace and go to the left, it's going to take a sweet little time. Look at the x values, right? See, it's like point whatever. Then all of a sudden it says x equals 0. And that's just because the calculator just doesn't know what to do at that point because you can't log 0. So anyway, it's just kind of bugging out a little bit. And by the way, we'll talk about transformations. Like if you do like a +1 here, and inside, let's say you do like let me insert like a -2. Let's go back to standard window. See how it gets shifted, but it's deceiving.
Because see, that shows there's an endpoint there, that's not true. It's not an endpoint there. It actually does go down forever. So TA4 calculus, actually I'm glad that Alex brought it up. Just
It's a little deceiving on the TA4 calculator. It's actually better. And you know what? Shortcut for typing logs and Desmos. Let's do the shortcut there. Maybe there's not one. Is there one? Do you guys see? Well, that's lame. Hold on. I guess not. All right, not a big deal. So you just click the keyboard. I think you click on functions. You scroll down, you should find log. Yep, there we go. The log base 2 of x. And if I lower the keyboard, you see it's still there. Like, or if I did a transformation like -2 plus 1, it doesn't end. It keeps going. So the TI4 calculus is a little deceiving. So you want to be mindful about that. Nothing I wanted to say about logs, which is escaping my head as of the current moment. Anyway, let's talk about this packet I just handed out to you guys. Oh, now I remember. For those who are doing the SAT, the juniors in here, logs are not covering the SAT. Don't worry about it. I've never seen logs, and I don't think that's going to change. ACT, they might, but they keep it pretty basic. Just for those who are juniors and doing SAT, or sophomores, don't worry about that next year. Okay, this packet here, and then we'll do the quiz after that. And let me just look at timing, make sure I'm not shortchange you guys on time. It's 18th, of course. Yeah, we're good. We're good. I only about like a few more minutes. So I want to talk about this packet here really quickly. So the homework is going to be in the notes packet we're working on, the second sheet. There's homework there. You guys are doing two things for homework. You guys are doing the typical homework I usually give. That's from the CPM online textbook, but I always make a copy for you guys, right? And then this packet here. This packet here has the answers on the second sheet. So don't be alarmed, like, oh my God, it's so long. No, the second sheet's the answers. But let me just show you what's happening. I'll do the odds for you guys. I'm going to do them kind of quickly. But it's a lot about just like rote skills. To be honest, that's really what it is. And I hate saying drill and kill, but you guys kind of need it. So that's just 36 equals 6 squared, right? The 36 stays where it is, 6 squared. That's just 1 over 196 equals 14 to -2, right? Because remember, the base gets risen to the side.
That's all. That's the empty box. That's the use that side. I'm gonna do all the odds.
Oh yeah, oh sorry, 14. That's 1 over 14 squared, right? Exactly. If you were to work that out, which of course is 1 over 196. Let's keep moving. So write this as a log now. So it's log base 64 of 8 equals 1/2. Log base 9, let me put this in parentheses, 1 over 81 equals -2. That's 64, by the way. A little hard to read. Yeah, that's all you're doing, right? Not that hard. For 9, same thing. 15 over 16 equals u to the v power. It's a little more abstract because you're given more letters. X equals 7/4 raised to the y power. I'll put this in parentheses just to be safe. But yeah, you keep the input where it is, so now it becomes output, and the base gets risen to the other side. So it's a lot of drill and kill, and you have the answers. The answers are connected to this. Like 13. V equals u to -16. Or for 15, log base u of v equals negative 14. Or for 17, log base of 1/5 of y equals x, right? So you're just rewriting. There's a lot of rewriting. There's not much to think about. There's not much brain power goes into this, right? This is the key concept, right? We talked about this. This is the whole essence of this unit. Right? There we go. X equals b to the y. X equals b to the y. Y equals log base bx. Here, tell me what you guys think. How am I gonna write this? What's my base for my log? And what's my input for it? X. And what's the other side? Y. There you go. Okay. Let's think about this one.
Four left power to 264. Read. 4 left power to 216. 5 left power to 125. Read. It's a little tricky. 343. It's gonna be a flash. It's getting small. It's giving me a root, guys.
Let me write the other three first really quickly. So remember, this was 3. This is 2. This is 3. Let me put a little box here. So 7 equals 343 raised to some power. How many times do you have to multiply 7 to 343?
7 times 7 is 49. If I multiply 7 again, you will get 343. It's 1/3. Thank you.
You see why else it's a fraction? It's a root. It's a radical. Yes. Yes. That's me 1/3. Because you gotta treat it like a radical. 100% correct. Yes. 29. Yeah. Good. You guys are getting it. This is lovely. Yeah, this is gonna be a good packet for you guys. And then we talked about this. Like if you see the base and this the same, we had this discussion already. They undo each other when that happens. It's a little different than what I had in the notes. The notes had the log first, and that's the exponential function inside. But the log is input of that exponential function.
They still undo each other as long as they undo each other.
So I'm confused as to what.
Goes back up a little bit. Are you talking about 31, 33? Yeah. So think of it like this. B to the x equals y. Or let me back a little bit. B to the y equals x. Remember, it was the same thing as saying this.
Yeah.
Log base b of x equals y. So let me color code it actually. This will take me a little longer, but this helped because I was actually tutoring one of my good friends' son is actually a sophomore too in East Bay. Kind of crazy. I'm now like actually working with my friends' kids. That kid's much later in life, but anyway, okay. So it's color code. 12. Well, it's a little bit of pain, but it's worth it. It's worth it to do it this way. So 12 is in B's position, right? The whole log thing is in Y's position. Log base 12, 144. The B value. Hold on. Let me make that red over here. And let me make these black. Just a tad annoying. Okay, here we go. So the B's in green is the B is green, right? So 12 is in B's position. But it's worth it. We're doing this. equals x, let's say, right? So now what are you going to do? You're going to write log. So hopefully, Alex, this helps. Well, for everyone else too. Log equals, okay. So what goes in the subscript? What goes in the green? The 12, right? And the x jumps over, right? And what happens to the red here? This entire red thing, that goes to the other side, right? What does x equal in this case? Exactly. No, 144. Sorry, 144. Right? Because x,
Oh,
yeah. So it's a transformation.
You're transforming this, so if you have all this jump here, this one goes here, this goes there, this goes there. So x has to equal that. So that's why these are the same, they undo each other, and the answer is that. Likewise here, so likewise here, likewise, well, actually, change the 93 squared first, that's, but
I'll let you guys battle with that one. Yeah, that one's actually a little funny. I think the answer for 34 is 400s. Yeah, I'll let you guys battle through that one. So those are kind of more advanced ones, I'd say. I'm more interested in the ones before 31. I'm more interested in that stuff. Okay. All right. So we're all set. I'm done with the lesson today.